I want to welcome you all to this training. And it's through our community, Ghana. They are coming up with this, and it is good that we all put ourselves into it. Again, this is in line with their annual ritual, or annual ritual, which has to do with the conferences we do have every year. And so we have decided to have this as part of our activities to see if we can also generate some little funds to support the work of the conference or the activities of the conference. So if you had registered or if you were registering, you saw a statement seeking to request for fund, then that is the meaning of that. Just the program is for free. Nobody is charging you for anything, but in your own free will, if you think that you want to support the conference with any amount, you can do that. Thank you very much. So I would want to start. Before I joined, I could hear from you people introducing yourselves, so there wouldn't be much time for me to ask for your names here and there. But this is me. I'm Napoleon. Works at UDS. An associate professor of epidemiology and biostatistics and data science. So I'm taking you through biostatistics with R. In fact, R is a modernized tool, though it has been long, but for its usage, especially some of us, it's modern. And again, comparatively, you compare to other software, its robustness would always let you choose it. So we want to use that. And once we have a whole society canvassing for R, we think that everything we do, we can link it up. And R can do so many things. So maybe after our training, you would keep on learning. Your interest will be equipped to do more in that. Before I start, I would love that all of us would change our names to our original names. Some of you have short, abridged forms of your names. And so I would plead that you write the correct name. So rename yourself, please. If your name is not properly, then rename it. Good. So we are looking at right from data to decision, because you can't use R without making decision. And the R is basically to aid you. It becomes the tool by which your concepts can be carried out. So what are we seeking to achieve in this training? Now, I want you to understand the basic concepts, biostatistics concepts, then use R for data analysis. Then, of course, when you use R for data analysis, you would be able to perform biostatistical tests, build models, then we will try and interpret and communicate results. So these are the main objectives, what we intend to achieve in this training. So I believe that by the time you're done, we'll be able to cope. And let me say that this will be 2-day training. And so let's take notice of that. Now, though it's 2 days, in fact, I've always made it 3 days as I have been doing. of course, I think that I can merge them the third day, and then we make it 2 days. Even if you ask me to do it one day, I will do it. But for the sake of understanding, we may go 2 days. So what are we, what are we achieving? We are saying that entering the world of data, and for that matter, we want to look at the basis of biostatistics. Our environment basics, importing and exploring data sets, data cleaning and handling. Then we will jump straight to, understand the testing. We'll jump to descriptive statistics, visualization, hypothesis testing, and t-test and chi-square test. Then we'll do a bit of modeling, where we use linear regression logistic. Then we interpret the outputs, then report findings. So when we say biostatistics, what does that mean? Of course, basically and literally, you can talk of biostatistics as applying statistics to biology. If you do apply to health statistics to health, it's called health statistics. When you apply to medicine, it's medical statistics. When you apply to population, that's the vital statistics, if you have heard it, for those who do demography. And so we also can talk about it as public. If you apply public health, it's also health statistics. So basically, that is the connotation and the meaning of it. But I dare tell you that biostatistics is more than computation, because at every point in time, it must carry evidence. In other words, whatever you carry out, any research you carry out in the clinical settings, it must be evidential. So please, anybody who joins must so comporting. We need to comport ourselves when we join group lectures. Please, let's do that for ourselves. Thank you. So, in other words, if you go to the hospital and you are a medical doctor, you are a nurse, you are a pharmacist, a laboratory technician here and there, or doctor or medical, whatsoever profession, the field you belong to, if you are a healthcare professional, you need to understand something called evidence-based, because every procedure, every action, every strategy you adopt, methodology you adopt, it must be evidential. And so it is very important we consider that based on the people we are handling, human beings. So we are saying that every data set will represent life, choices, and realities. So it's not about fixations. It's not about assumptions, but realities. When you code in R, you are not merely running commands. You are interpreting fragments of human experiences. So at the end of the day, the tool that can help you do this evidence-based is the R. So the moment you run R, you are dealing with human experiences. So that is what you need to understand. Now, so biostatistics, what does it seek to achieve? One, there are situations where you only describe the realities. So summaries of biological realities. In other words, if I'm summarizing any concept, anything, any event, any element, any variable, then I'm looking at, you can look at the age, I can look at the baseline pressure.
I'm better requesting for record too.
Now, please, you are disturbing us. Francis, please mute anybody who disturbs, interrupts.
Yes,
Please.
I'm doing that. I'm working on that.
Now, you can do description of your biological data when you just look at the summary of the data, or sometimes you look at the diagrammatical representation of the data, or sometimes you just look at either you look at the summary or how the data is spread in terms of variation or in terms of the central theme or the diagrammatic feature of the data. So that would constitute what we call description. Now in Frenchia, you want to go beyond just the description. In other words, you are no more interested in the summaries. You are no more interested in the spread. You are no more interested in sometimes the graphs, but you want to do something that call for testing. So in other words, when there is generalization or conclusion, or you want to estimate, or better still hypothesize, then you go to the realms of differential. So sometimes depending on what you want to do, especially with your objective, you would know how to measure it. Then there is tests which validate critical hypothesis. So at the end of the day, you have set your hypothesis. It must be tested. And so we have other statistical techniques we can use to test. Then we can look at modeling, map complex relationship to predict future disease risk. Is it possible for us to predict that when somebody comes to the hospital, there is tendency of being diagnosed of hypertension or diabetes or any other diseases based on the indicators? So we can model. So in epidemiology and public health, this compass guides decisions that affect the entire community. So it's basically the community, and this is mostly epidemiological concepts for which we can use the biostatistics to deal with. Now, again, we build what we call analysis, or build for analysis. You handles massive data set elegantly. Native to statistical calculation with fast ecosystem of specialized packages. So once you want to do the analysis, once you get the concept to develop, there is a tendency to have the tool. And so anytime you want to do some analysis and techniques, like for instance, survival analysis, we have it package for that in R. When you want to do kind of any calculations here and there are the deep layer you can use. Reveals the hidden structure of the data. So at the end of the day, when I have these packages, I will be able to unravel the mystery within the data set, especially with the biological data. In fact, R is not restricted to only biological data. I sometimes use it for economics data, business data, any field at all because of my background. And so I do all these things. Now, visualization too. So if you are interested in the analysis of other what we call statistical techniques, you can use, but when you are interested in visualization, the JJ plot too is good for you. That is the package. And that is what we may be using. Now, let's shift our attention to what biostatistics present and what R tooling or R2 can be used. In other words, what R can bring to us to unravel the mystery within descriptive statistics, data visualization, hypothesis testing, regression, survival analysis. So anytime your technique is about trying to come up with descriptive statistics. So for instance, if you read papers, some of you are postgraduate students and what have you, even the first degree students, if you cultivate the habit of reading papers, sometimes you read paper and you see mean, somebody, the paper presenting mean, presenting median, presenting interquartile range, presenting median. The moment you see that, you understand that that is a descriptive statistics. Of course, when you see that, sometimes they present the mean and then standard deviation. And that should tell you that you are dealing with kind of normal distribution data. But sometimes when you see the mean, median, and then the interquartile range, then your data is skewed. So all these things constitute the descriptive statistics. So when you want to do the mean into bracket, what the data to give you, or the variable to give you standard deviation, you can get the summary statistics. In other words, when you look at the summary statistics, it means you are both looking at the central part and the dispersed part. So the central part would definitely be the averages, mean, median, mode, and then the dispersed portion will be the standard deviation, the variance, the interquartile range here and there. Now, when it's data visualization, the R tool you can use, which is the package, is the ggplot2. Now, what does the distribution and the spread look like? So visualization will tell you that. If you want to ask a question, what does the distribution look like? Maybe I have a distribution on pains. How does it look like? Then you definitely need what we call visualization to unravel that. And that tool that can help you, ggplot2. Hypothesis testing, you see there's t-test, there's chi-square test, all these things. So anytime your objective is to observe differences or difference statistically, so maybe between categorical terms, you should be able to use chi-square or t-test. Now, regression to linear models, LM, these are the packages we will need. LM, general linear models, LM is linear models, GLM, general linear models. So what underlying factors? Anytime you want to predict factors, you can use regression. Of course, survival analysis, event to time, predicted event, the probability of an event occurring with time. How does time itself impact the probability of life, survival? So these are very tooling, our tooling we can use for any of the biostatistical questions you may ask. Now, what is the journey of evidence? What exactly do you do? Now, for you to be able to establish that evidence, there are procedure steps involved. One, be able to import your data. And in R, whenever you hear of read.sv, it means that we want to read the data, wherever it is, we want to pick it from. Then the moment you import your data, the next thing you do is to clean the data. So you see that the package that can help you clean the data is DPL. Very important. Now, the next thing you can do when you get your data within the system is to explore and plot. Is to do what? Explore and plot. Now, the other thing you can also do is to look at how you can test the statistics. You can do the test. It's very important. You don't joke with that. It's very important. How do you test it? statistical test. Is there any statistical test you can do? If it is there, then you do the hypothesis testing of your variables, right? Then you can build models. Having built the models, you interpret. Then you communicate the findings. Very important. So these are the steps involved. Anybody who has an objective and want to carry out biostatistical activity in R, there must be an input, there must be clean, there must be exploring, there must be test, there must be model, there must be interpretation of results and communication. Each step is a movement from raw observation to refined truths. Because at the end of the day, what you come as a result is the evidence. Now, for example, if you have blood pressure and treatment, one being treating with drug and then control. Now we have plotted this. You will see the drug has the diagram is called box plot. And so 2 box plots have been done. Now, if you look at the 2 box plots, you can see a significant difference. The blue and the red, there is very significant difference. And no wonder the p-value is less than 0.05. So I dare tell you that when you look at this diagram, you can quickly say that those who were treated with drug have lower BP compared to those with control. Please, who is asking a question? You can go ahead. Hello? Are you asking a question? We should go on. Okay. So quickly, you will be able to see. Now, if I want to visualize what is there, all what I need to do is to go to R, install the package, Prof plot, then I bring my data, I have ES, S treatment, and then it will definitely draw this box plot for me. If I want to do the test, or what I need to do, because all what I need to do, there are 2 categorical variables with 1 continuous variable. So this means that I can do what we call t-tests. So Insight will tell you that statistic. Please, somebody is disturbing us. Somebody says, can I come again with the interpretation of the p-value? Okay. What I'm saying is that before you even look at the p-value, look at the graph. Look at how the 2 diagrams differ. So you can even look at the differences within the graph and say that there's kind of statistical difference. But of course, you can suspect and then you test. But once I see this graph, nobody should tell me that it will be statistically significant. But of course, I also trust you need to test. They are far different, so that would resonate with statistical difference. But then you can see that the p-value is there to evidential to you. So once the p-value is less than 0.05, it means that there is difference between those who were given the drug and those who were not given the drug. And that those given the drug happen to have their BP lowered compared to those who were not given the drug. I hope it is clear. So with this R command, we can plot what is there. So that makes R beautiful. Now we can also have another one, that is modeling regression. We want to see whether treatment and age can predict blood pressure. Treatment and age can predict blood pressure. So in other words, we are using blood pressure as the dependent variable, and then treatment and age as independent variable. And of course, if you want to do this, you need a linear model. That linear model is a regression. So if you remember your regression well, this is what we called multiple linear regression, because the independent variables are more than one. So this, with the invention of, or with the writing of this model, how it is stated there, the result will just pop out. So R is beautiful. Does the treatment, so now the question is, does the treatment still matter after accounting for age? How strongly does age influence blood pressure independently? So at the end of the day, we want to look at the influence of age on blood pressure, the influence of treatment on blood pressure. And I say that numbers become knowledge. We move beyond raw correlation into predictive explanation. What that means is that, you see, once you have two numerical control continuous variable, you can do correlation, because correlation exists among continuous variables. But then that would only show you the relationship. But in terms of predicting, we go beyond that. And of course, correlation always is the that gives you clue to know whether it is good to be predicted. So when you see that there is correlation between two variables, then there's a tendency of you having the ability to predict. So we need to take notice of that. And the program from data to decision, training. So when we say we are training you biostatistics, it's not merely a transfer of skills. It is an awakening of sight. You are equipping mind to see patterns. So at the end of the day, I just want you to see that pattern, especially if it's modeling, if it is relationship, whatever, visualization, just see those patterns and we move on. Now, we can talk about the environment. We would give ourselves some data, and then we would do whatever we have said in terms of doing biostatistics with R. So the hands-on would go on. So let's move on to the hands-on. Before I do the hands-on, I would love that we go through the packages so that you know what exactly we are talking about. Now, I said that if you could cast your mind to the various steps, the pathway to evidence, you would know that we talk about the required packages. You cannot do R without the required package. You need the packages to do it. So if you want to install package, what you need to do is to just bring library, then into bracket, the package you want. Tidyverse is there, you can install. Because of what we are going to do, Tidyverse is able to do a lot for us. Then if you want to plot to, we have the JJ-plot2. That will also help us do a lot of plotting visualization. I'm not saying that this is the only package for plotting, that for the sake of what we are doing, this can help us. So if I want to do it, all of them together, install them together, I can do the combined. In fact, there is R training, for a basic R training for those beginners. So when you do that, you would understand this combination here and there. But for now, we want to do biostatistics with R. So just get the concept and then you build it from somewhere. So this is what you need to, you require package. Then when you are done with the package, I told you you do what? Import your data. So either you set working directory, adjust paths. So you set WD, you go through the paths, maybe your computer where you have put it, maybe at the desktop, you go and pick it from there. Or you import the data. So for instance, I would just say that the data is equals to read.csv, then I bring the data name. The moment I import into the R, what that means is that I can now view the first rows, the headings. I can view it and see. So with I want to maybe I'm not sure. I was having similar data. So then I would check it to see whether it's that same data. I will do it. Then I would be able to check the structure of the data. Then I can do my exploring. This is our exploring. I can check my summary statistics. I was talking to you about cleaning the data, so I can check missing values, whether there are missing data or values within the data set. I can check all of them. Then, the moment I put in categorical variables, I need to convert it to factors so that my R can read it well and use it for what I would ask it to do. So for instance, the data I want to use, there is gender. You know the gender, we may have maybe male and female. So I make it a factor. So that's why I said, now the data gender, if you go to the data, the name of the data is data. Data set is data. Now within the data set, pick gender. And when you pick gender, change it to factor. That is as.factor. Then that would be the data. Do it on the data set and pick gender and do it on. I'll pick again treatment. You know the treatment control and either control or drag. So I pick those ones to categorical. I change it to factor. So always just bear this one in mind. If you want to be dealing with your biostatistical data with what we call R, your categorical variables must be changed to factors so that you'll be able to execute what you want to execute. Very important. Then we can look at smoking, whether the person smokes or not, you can do. Then the diseases, where did you have the hypertension or not? So the diseases too is, you make it a factor. Once it's categorical, you do it. Then, of course, I need to remove, if I checked, first we check for missing values. If I check and there's missing value, all what I need to do is to remove the missing values. Remove them. Say, please, why do you think that we don't do any estimation, but we are removing it? Or in other words, do you think it's good? Let me put it this way. Do you think it's good to remove the missing values? Please, I'm looking at your answers. Yes. Put it at the chat box. Okay, is it good to remove the J? You say yes. And what is the effect? If you remove it, who can put it in the chat? What is the effect? Yes. Who can tell me the effects? This one is not just biostatistics, it cut across every field. If you have a data and you remove, yes, well, accuracy because it will mess up, sample size reduced. When the sample size is reduced, what happens? It depends. It depends on what? Okay, so thank you for answering. Good. So, reduces the error. Okay. Now, the main reason why we don't want you to reduce the sample size is that if you do, the precision, yes, which means that it affects the statistical power. It affects the statistical power. In other words, the reliability is hampered. Accuracy may be hampered. So we always would want large sample size. And once large sample size, you know that it means that your data will be normally distributed. So, and we are always expecting that our data set must be large so that it becomes an unbiased estimator of the population parameter. So in other words, the statistic must be unbiased estimator of the population parameter. Good. So let's move on. And thank you for answering. Then the moment you remove, but of course, if it's missing, you can't do anything about it. You need to remove it. So R, because of the sensitive nature of R, if you don't take time, it will just conclusively box it up and give you a result, which might not be a rare representation. So we need to remove them. And so removing them, you, at the end of the day, verify the changes of your data. You just enter this, it will come. You enter what is written there, it will come. Now from there, haven't worked on my data, cleaned my data, exploit the data, even known the exact data I'm working with. I can continue to do my descriptive statistics. So for the descriptive statistics, of course, I have already told you, we do what we call statistical indicators. We look for our statistical indicators. We can look for our diagrams or the graphs or the charts. Can look at them. Now, if I want the mean and then the standard deviation, it's simple. That is the very simplest R command you can get. You just enter mean, then into bracket the data you are working with, it will give you the mean. Standard deviation, SD, and into bracket the data you are working with, it will give you. We'll demonstrate it and you see. Summary by treatment group. I want the treatment group. I want the summary of the treatment group. At the end of the day, I want to know the mean for those who took the drug and the mean for those who didn't take the drug. So I use aggregate. The blood pressure is the name of the data. Then I do treatment. Treatment is what I want to aggregate it with respect to the blood pressure. The mean of blood pressure for those who took drug, and the mean of blood pressure for those who did not take the drug. So that is the we can use. Now let's go to the summary by gender. Gender too, we can males, the mean blood pressure for males, the mean blood pressure for females. We can do that to do it. Then we can do tables. So table, and then we have what? Data, $, gender. So out of the data, we want to pick gender, do a table for. So at the end of the day, if you are doing table, that's what we call the frequency table. You can have maybe gender, the number, female, the male, the number, female, the number. Then the table, we are looking at smoking, those who smoke and those who don't smoke. So we also get frequency table for them. So all these things are command. The visualization. So the visualization to our command that will help you change a plot. Now the data, the name of the data is the AES, which will give you the tricks, the X and Y. Then we have the genome underscore box plot. This GUM would let you be able to draw the box plots. Okay, plus the team and minimal. This is the command you will use. Then the bar chart through the command is there. Histogram through the command is there. The bandwidth in terms of the boxes. The bar chart through the command is there. The scatter plot through the command is there. You know, scatter plot, we use it for two continuous data. We want to find a linear relationship. Now, if you look at visualization, there's, you see, it is not chart any data at all. Every variable has that you can use for quantitative. You will use graphs. If the variable is qualitative, you will use qualitative graphs. So for instance, if I want to plot a graph for age variable, I know that age is quantitative. So I cannot use any qualitative graph. So what are the qualitative graphs? Pie chart, bar chart, pictogram, and etc. What are the quantitative graphs? You know of histogram, you know frequency polygon, the cumulative frequency, you know of the scatter plot. You also know of box and whisker plot. You know of stem and leaf. So these are quantitative. There are many of them. Sometimes heat map and what have you. So there are many of them. And so if there are many, you use it for only quantitative variables all the time. So the age I mentioned, who can tell me what graph can do for age? Yes, put it on the chat box. I'm just looking at it. Okay, box plot, yes. Histogram, yes. Yes. You are many, so don't behave as if there are two people. 64 is not easy. Yes, yes. Stem and leaf. Yes, I like your leaf. Yes. Histogram. Yes, what again? Okay, I think you have ample idea, so we can move on. Somebody asks whether we are treating age as continuous or group. Age is continuous. Age is continuous. Age is continuous. It is when you manipulate it, or there is something called data manipulation or data transformation. Whenever you can transform quantitative data into qualitative data, but it doesn't take its original state from it. Okay. So that is something we need to take notice of. Now let's move on. You've done well. So for instance, when you want to plot bar charts, you should know that the data for bar chart or the variable for bar chart must be qualitative. So look at it, smoking. Smoking is qualitative. Let's look at scatter plot. And I've told you scatter plot involves two continuous data. So let's look at the data involved. You see age and you see blood pressure. So let's look at bar chart. What is there? Smoking. Let's look at box plot. You see as blood pressure and then treatment. You know why? Because box plots can be categorized based on the continuous variable. So if you have a categorized variable or data that you want to find its continuous correspondence in terms of another variable, you can use box plots. I hope it's clear. Okay. Okay, so the next thing we will do is hypothesis testing. And for the hypothesis testing, we are only using the t-tests. We'll use the t-tests. Now, when do you use t-tests? I believe those of you who have done some biostatistics or statistics may know that the moment t-test comes in, we are looking at two variables. One variable can be continuous, and another variable can be categorical. And that categorical variable must have only two options. For instance, gender, male and female. Smoking, yes or no. So that you can find the t-test. Of course, there are three types of t-tests. We have the one sample t-test. We have the pair t-test, and we have the independent, two sample independent t-test. Now, the one sample dependent t-test is just only one sample that you check. Somebody is asking me why t-test when the sample size is less. than 30. Oh, the person is answering. So why t-test? Because our interest is to find our interest is to find the mean involving two options. For that matter, any categorical variable with two options with a dependent variable which is continuous, we need t-tests. So what that means is that, for instance, I want to know male and female who exercise a lot. So in other words, I will look at the rate of exercise among the two options. So gender, you see there are two. I want to also look at perhaps those who are sick and those who are not sick, who listen to music a lot. So diseases and maybe music listening. Are you okay? So I will rate the music listening and then compare it among those who are sick and those who are. So if you look at these scenarios, you see that the categorical variable only gives us two options. And so we can use t-test. So that is the test in R. We can use the t.test and then run it. Now, when you see here, the t is data is equals data. As for the data is there, because the name of our data is also data. That's why I say data is equals data. If I change the name of my data to sample, you will see that here is data is equals to sample. So just bear in mind. Okay. Now let's look at chi-square tests. Now the t-tests, our interest was on one dependent and independent. The dependent is always continuous. The independent is always categorical. And there are two options. Now, chi-square tests. Is smoking associated with diseases? Now look at this something. What do you look at? Smoking. What type of variable? Disease, what type of variable? Just put it on the chat box. Let me see who and who. Yes, good. Let's move on. Yes, both are categorical. Smoking is categorical, disease is also categorical. Correct. Good. So now, then let me ask this question. What does it mean if the two variables are categorical? What does it tell you about chi-square test? Who can answer that? Hello. I hope the question is clear. If the two variables are categorical, then what does it tell us when you use chi-square? Good. Measures association between two categories, correct? To establish the association between two categories, test the relationship to category. Yeah. So you get to understand that if your variables are not categorical, you cannot use chi-square tests. So in that case, the association between exposure, I've seen that somebody said the association between exposure and outcome. It means that your exposure must be categorical and your outcome must be categorical. So the exposure may be smoking, and then your outcome may be the diseases. Okay. So you need to look at that. No. For a chi-square, you don't look for influencing. You only look for association or relationship. The other ones, especially with the continuous, then you can look at influencing factors and what have you. What word is this? Significance. Is it significance? Well, it's up to the person. Okay, so you can see. So create contingency table. If you don't create contingency table, you cannot do chi-square in R. And even in the normal manual way of calculating the chi-square, you cannot do it. So contingency table is just the cross tabulation. For instance, if you have people who are smoking, yes or no, people who have the diseases, yes or no, and then you cross them. So at the end of the day, crossing them, you will know number of people who are smoking and they have the disease, number of people who are smoking and they don't have the disease, number of people who are not smoking, they have the disease, number of people who are smoking, they have. So that is cross tabulation. You need to first have that contingency table before you then run the test. And the test is test table. All these things, we can use Excel to run them. But because we want to also look at R, which is the robust you can have, and because of our domain, because I've done another workshop that we use Excel to run all these things. So let's move on. Linear regression. That is where you need dependent and independent, and you must ensure that the dependent is continuous. So for instance, if I want to predict blood pressure with age, treatment, and smoking, this will be my model. Blood pressure with age, treatment, and smoking. Data is equals to data, depending on the name you have given it. Then after that, I will summarize the model, the findings, or the results. So this would help us do all what we want to do. Then I go to logistic regression. This one, you see, regression was used to predict continuous variable. Logistic is used to predict categorical variable. So disease is binary, yes or no. If I want to predict whether you get the diseases or not, I can't use regression, but I can use logistic regression. So normally, logistic regression is the prediction for qualitative variables, and linear regression is the predictive model or prediction for continuous variable. I hope it's clear. So sometimes people get confused, especially when they are doing their research and as they want to do prediction, you see that any type of variable, the person is using regression. No, what you need to understand is that regression will solely go for qualitative data or variable. And again, you should also know the types of options you have, the qualitative data. Some may be just binary, it means yes or no, two. The options may be two. Some two, the options may be 3, 4, and what have you. So you should know what kind of dependent variable you are predicting. It's very important. Now, if it is only 2, the options are 2. That is where we can look at the simple logistic regression, but you can have multinomial logistic regression, which means that the prediction of the dependent variable has more than two options. It's more than two options. So this is it. We are using the distribution binomial. So we need to have a binomial distribution. We'll summarize it. Conclusion. In R, every command is more than syntax. It is a question posed to reality. And every output is an answer. Of course, every output is an answer, waiting for interpretation with clarity and integrity. So I think I will bring our theory. I will end it here. If there's any question, you can ask, and then you can put it on the chat box. I will read it. I will answer it. I'll answer it, then I'll move on. So because now we want to move on to the practicals. Now that you have been made aware of some of the R packages and tooling, when we see them, we can relate. So if there's no question, let me continue. I will stop sharing. And now try and share. Try and share my R. I hope you know how to install R. Or if you know how to install R, that shouldn't be a problem. So let me okay. I don't know whether when we finish the R, community will give you the materials. If they will give you the materials, we would add the steps involved. So please, we would ensure that they aid you through. So we'll get you an aid to install it, and where you get it. You know, it's an open source and it's free, so you will definitely get it. Perhaps the R community would just get you what we called the resource materials. Don't know how they will do it, but I know they will do it. The founder is around, so. Okay, so we are going to start. I would want to load my Can you all see my screen, please? Okay, good. This means you can see it. Good, great. Now let's move on. The first thing we do, we're talking about installing the various, what do you call it? But before then, let's see how we can import our data. I've always said that I am so lazy. So what I normally do is I go through the interface to get my data installed. And my data, I want to save it. So first of all, this is my data. Let me save it as data sample. Let me make it sample one. Sample one. Sample one. Good. Okay, I've done that. Now, that is my data. I want to use that data. The data is on control, like how I used to teach you. Now, okay, don't worry. Now let me go. This is how you do. You go to File. You go to Import Data Set from Excel. I have it in Excel. As you can have the CSV too. So I will click on it. Now, where there is browse, please can you all see? Can you see the screen? Okay, go to where there is browse. Click on it. When I click on it, I need to look for where I've put the data. I think the data is that all of you will look for R conference. And then I save it as sample one. Then I click on open. The moment I click on open, why? Let me see. Maybe I didn't save it as CSV. Let me save it as CSV. That's why I'm getting that from. So let me save it as CSV. Oh, it's CSV. Okay. Can I establish that the input is either S, L, Y? Never mind, we'll get through. Okay. So this is the data. I will import it. So I've imported my data. Can you all see the screen?
Yes, Prof.
Yeah.
Sorry to interrupt. Please, is it possible to share the dummy data with us?
Let me give it to Francis. Okay. So I will share it. Yes, I have shared it with our community founder. He would give
Yes,
it
I'll
to
work on
you.
it right now. I'll work on it and then I'll
Yeah.
put it on the page. So check on the WhatsApp group page, but I will try to upload it to on the using the comment section. So check.
Okay, so let's quickly move on. So what are we to do? Now you can see in R, those of you who have used R before, where the blue link is, we normally call it console. That's where whatever you execute comes. Now, where we have the data set, are you okay? The data set, where we have it, is where we can do the execution. Ensure that whatever we want to execute, we give the command there. Now, there are some other portions here, the environment. That is where you would have all your commands, whatever, coming to stay there, whatever activity, you will see it there. Then we have the last portion, which has to do we have the last portion where we have the packages. Sometimes when you have any visualization, it's presented there. And that is where you can see install, update, you can update your packages. So these blue things you see are packages you can update. So there and there, that is the where you can also look for all the commands. In R, there are built-in commands. Sometimes you may not really comprehend what you want to do. So you can go there and then look for them and use it. You can copy and come and use it. So these four things as their separate roles, what they perform. As we move on, you will definitely understand how these things are done and you will be able to relate. So now let's quickly, now let's see how we can, let me see if I can create. Come in. My listing is freezed. Let me see. Okay. All these things are there. Let me. Okay. Okay. I wanted to clear some of them. So I've created a new. Now the question is, how do I start? Already the data has been imported. You get it? The data has been imported. So I can just, this one is view the data. That is why it has come. I can copy it and put it there, the directory here as part of my execution. Okay. So I can put it there. So the moment I view sample, it means that I want to look at the data sets view. Anytime you give it view, so let me show you. You have this, then you run, you click on it. Wow. Come in. Okay, so what it means is that the data has already been installed in the system and we have done it. We'll go over it and redo it. But of course, we can delete it and we go and redo it again for you to appreciate how it's done. So you go to File, you import from Excel. I save it at our conference. Let me see where our conference is. So this is our conference. Good. Sample, the name of the data is sample. Now you can see that the first row has names. I've done that. And I import it. The moment I import it, it comes. So it has recorded sample. How many observations? This. So now we can start our, the directory has been given to us. This is where you can see, you remember the read CSV, read.csv thing I spoke about. Now, what can we do? We said that we can import our data. Now, after that, we look for the packages required. The packages required. What are the packages required? Who can tell us? We need plot 2, and then what? So let's go to library. Library, we need our plot 2. Remember, because we need to install the packages. plot 2. So you can run it, then run it here. Is there, then which one again do we need? Library. You remember library, tidal wave? You remember? So we need a tidal wave. Yeah. Okay. So let me get the tidal verse to there. But of course, I have the course here. I may be delaying if I want to write it one after the other. So I'm just going to paste the entire thing there so that we would appreciate it and do it one after the other. Okay, good. So the tidy verse is there. Let me also run it. I've run it. So now that I have the ggplot tidy and what have you. Okay. Okay. Now I've imported it, so I don't need this one. Now what is happening that once our data is sampled, is correct here, I want to check the headings, whether it's the right sample I have. So this one is view first row. Then you use the heading. So you use the heading. You want to see the heading. As soon as you do it, you know. You have the heading, the age, gender, treatment, smoking, blood pressure, diseases. Now, can I also look at the structure of the data? How is the structure looking like? So the structure will tell you some is string, some is there's some to data frame and what have you. So this, if you are doing the basics, they will tell you the type of uh, the data you would have and then the structure. The structure is very important. They would teach you that one too. But for now, this is not our main concept. Then can I do the summary statistics? Anytime I want to do summary statistics, it means that I want the averages, statistical indicators. So let me see. Can I get my statistical indicators? Yes. How do I get it? I just write summary and then write the data name, which is what? Sample. So let me click on the run. So now can you see? So simple. Say we have the minimum, the first quarter, the median, the mean, the third quarter maximum. So each of them, age. So the age, we have the minimum to be 25. The first quarter, 35. Median is 48. Mean is 47.2. Third quarter, 59. Maximum is 69. So the maximum value is 69. The minimum value is what? 25. The blood pressure too, you can see that. Oh, sorry, my voice is down. Is it now okay? I hope it's okay now. Okay, can you hear me now? Good. Good. Now let's move on. So this summary statistics will give you the indicators, both the averages and then the dispersed. Okay. Now, having done that, I need to check whether there is missing values or not. Missing values or not. So I have the column sums, which would now tell me what the missing data is in my sample, which is the data set. So I can run it and then get my, wow, there's no missing data. It means my data is intact. Age, missing data is 0, gender is 0, treatment is 0, blood pressure 0, disease 0. So I think it's good. So in this case, once we were looking at the first instant, if you have a missing data, you remove it. This time around, we have checked our data and there's no missing data. So I dare to say that we will not remove anything. Will not remove anything. So when I come to removing of the missing data, I won't go. Other than that, I would have just removed the missing data. So removing missing data, I just need my sample, the NA, then omit whatever is the missing data. It will just clear it. But then you remember the cleaning. I've established missing data, I will remove it. Then again, I know that gender is categorical, treatment is categorical, smoking is categorical, disease is categorical. So I need to send them, convert it to factors. So I will first of all click on gender and then run. I can let all of them run together. I can just decide to run them together. R would accept it. So R has run them together. So R is nice. Now, the moment I remove the missing values or data, I can still look at the structure, verify it, and see. I hope it's clear. Okay. Now, if you are able to do this, the next thing you do is to now run your data. If you have finished cleaning the data, you can now run your data. Good. So let's try and run the data. The basic statistics or the preliminary statistics or descriptive statistics. So I need to do my mean. How do I do the mean from the data sets? I can just run, I said that one is simple. Just write mean. You run your mean and then you put in the data set. So now you can see that the descriptive, the mean is not there. The data set is there. We want to run mean for what? Blood pressure. So normally you take the sample, you write the sample, you bring the dollar sign, and then you bring the particular variable you want to run the mean for. So let's move on. So we go there. We want to run mean for blood pressure in the sample data sets. So is the mean there? Let's go and see. Okay. So it means that the mean for blood pressure is 127, which is normal, right? Now let's go and do the standard deviation. The sample is there, so the data is there. Sample. So you run it, you highlight and run it. The sample, the standard deviation is 15.20. So I think it's also clear, right? That the standard deviation is 15. It means that for every mean value, the deviation is about 15. The deviation is about 15 on the spread from the mean. Good. So we now look at summary of the treatment group. We want to look at the mean of the blood pressure for the drug and the mean of the blood pressure for those without drug. So you do aggregate, you do blood pressure because we want to find for the blood pressure, the mean of the blood pressure for the two groups. So the sample and then the mean. So let's highlight it. And then you run it. What do you get? So you get your control. The mean for the control is what? 126. And the mean for the drug is 127. Wow. So you see that a bit, you look at those with drug are a bit higher than those with control in terms of blood pressure. But they are all within the normal range. They are all within the normal range. Now we can do it for gender. The mean blood pressure for males, blood pressure for females, which one is higher? So let's go there and also do that. And of course, the same code. You use the same code. R is very beautiful. And when you use the R, especially when you know the code, the work is so easy. And now to get the code to is so. If you don't have it and it's difficult to write, see the R community, they will do it for you. They are experts. Now let's look at it. What do you see? You can see that the males to the females blood pressure is lesser than the males, right? Now, can we draw some tables? Yes, we can draw a table for gender. We want to know the frequency table. So, have you seen that the frequency, male is what? 53, female is what? 67. So, males are recording the highest. If you like the percentage, you can add it and get the percentage. Now, gender too. Let's look at gender. Gender. It's also those smoking. We are looking at smoking. We first looked at gender. Smoking. Those who smoke, they are 57. Those who don't smoke are 63. I think it's clear. Now I don't know the time. I think we still have time. So we
that's
can do the
8:30. Yeah, 3.
When are we closing?
We are closing 9, but then if we can close even 8:40, I think it should be okay.
Okay, so that we get time to talk to. That's okay. So now we've been able to do the descriptive statistics. So there's nothing difficult. It's just they are simple, especially with the codes. You can just run it for any data. You know, R In fact, R encourages you, especially when you have a big data set. That is the essence of R. It can accommodate big data sets, or big data, as you always say it. Good. Now, let me do some bit of visualization for you for the data we have. We have the data as we have described, data that seems to record treatments. Some patients were given drugs, some were not given drugs. At the end of the day, those who were given that the outcome is disease, whether they have the disease or not. And then we looked at their age, we looked at their gender, we looked at they were smoking. So at the end of the day, if you are smoking and they give you treatment, will you have the disease or not? Maybe lung cancer or not? So that is exactly what we are looking at. So let's look at some of the visualization. If it is a box plot, we should know we should have one categorical, one word, continuous. So let's enjoy this. Let's enjoy the visualization. Okay. Good. The first visualization we want to do is box plot. And how do we do that? We want to pick up JJ plot. You remember the JJ plot, right? Then we have the sample, which is the name of the data. Then we have these ones are just to let you know that they are going to plot with specification. So AES is also a code. You need to bring it. S is equals to treatment. That is, it means that we want S to be, the treatment to be on the S axis. Y is equal to blood pressure. It means that blood pressure should be on Y axis. And then what are we plotting? We are plotting both plots. Then the minimal. So we want to have in terms of convergence up to the minimum. So now let's highlight and then run. Good. Somebody should tell me something. You see, we are not seeing the color. On my presentation, you saw the color. If you don't bring the color specifications, it must be color, it won't come. It will give you the raw thing like this. So if you want to beautify it, you just add the colors and it will just pick it up. Okay, good. Now, who can help us interpret this? Yes, the chat forum is open. We have two main diagrams. Who can help us interpret that? Yes, who is that? Who is telling us? I'm monitoring the chat. What's happening? What do you think is happening there? I hope you can see that the S-axis is the treatment and then the Y-axis is the blood. You can see that I said when it is about chart and whatever, it comes here. If it is about the data and the execution you do, it must be coming here. Now let's see. What do you see? Let me see. Let me say that the median. Okay, somebody has spoken. Can I try, Prof? Try.
Good evening, Prof.
Yes.
Good evening, colleagues.
Good.
So the box plot shows what we call the 5 interquarter values. That is the minimum, maximum, the median, and then the mean for the control, and then those who were tested with the drug.
Okay.
I'm done, Prof.
Okay. Somebody too said there seems to no difference. There seems to be no difference in the pressure of both treatment and control. Wow. Okay. It seems you see, whenever you are describing or explaining or interpreting post plots, the first thing you look at for is the median, the middle value. So if you look at the middle value, it seems they are the same, right?
They're not the same,
So
no.
it's not the same, eh?
They are the one is slightly above the other.
The control is slightly above the drug.
Okay, so
No, it's
it
not the
means
same.
You check,
so
when you check, it's like there's some slight difference though.
There's a slight difference. It's like
okay,
the
so
Slight difference.
that's okay. So granted that the control is above the drug, what that means is that those with control seems to have a bit of higher blood pressure compared to those with drug. Hello, I hope it's clear. But I can easily look at this and say that I don't see any significant change. But we have not tested. We'll do the testing, right?
sure.
I can. There's no. Well, that's okay. So we can. When you look at it literally, you can see that those who were pushing to the control seems to have their blood pressure a bit higher compared to those who were given the drug. So this is how you can interpret it. Okay. This is how you can interpret it. Good. Now, this is just post plot. It is not, we did not test. This is just post plot. So now let's look at how we can do bar graph. So we'll run it. As for bar graph, even if I don't ask you, you know. So virtually, you can easily say that yes, those who smoke are less than those who don't smoke. Obviously, you can see it. Now, let me run a histogram, one of the quantitative, so that histogram and pie chart. Then when we meet again, we can do the scatter plot. So histogram, so let's do it. They say, have you seen the histogram? It's combined, right? This histogram, how do you see it? It looks more of what? Is it a normal distribution or skewed?
It's a normal distribution.
It's a normal distribution, Prof.
That's all. Okay, so
Skewed. Prof,
are
I
you
think
sure?
it's skewed. It's skewed because when you look at even the highest number, and then the lowest number, there's a more differences to it.
Okay, so sometimes you aren't able to see in terms of the display. So you do test it. Very important. You can test it. You can find a yes, who is speaking? Okay. Some said normal, some say normal. I've told you if you are using a nickname, Write your full name.
Number class.
Francis.
Man, online class. I'm saying not
Francis.
follow mama. Not follow mama. Mom te bo kote mo buda.
I'm working on it.
Okay, good. Now let's me do the pie chart. These are raw charts. You can make it look nicer. These are simple charts. So once you do the count, then you come and then do the plots. You count it and plot. So you see, smoking distribution. Those who don't smoke are more than those who smoke. And these are the things you need to take notice of. Okay, so because we don't want to do last one, the last one I will do is the scatter plot. The scatter plot. You know, out of the scatter plot, you'll be able to tell, especially with the prediction. So the scatter plot is looking at age and what? Blood pressure. Age and whether there is relationship between age and blood pressure. So we do this, and then we run. Can you see the diagram, what it has brought? What can you say about it? Hello? Any comment? Give it on the comment section, the box. So you see there are 20, 120, so the dots are 120. But of course, if you look at it critically, it's closer to some of them. But it is almost getting to what we call the horizontal line. And it's becoming dangerous. Somebody said it's a normal distribution. Wow. Non-linear. Wow. Somebody said no relationship. Okay, so 3 people. Okay, so it could be that this person is much. Wow. Who is US user? You don't have a name. Good. So if you look at it critically, it seems to me it nearly gets into nearly looking like a horizontal line. And of course, when you want to look at the linear relationship, it must be slopey. That's why we have the gradient or the degree or the slope. And then we have the constant. So this one seems not to have it. So some may say there's no relationship. Some may say it is non-linear. It's non-linear. But it doesn't mean if it's non-linear, it doesn't mean that there's no relationship. Okay. But if it's linear, you may be tempted to say there's no relationship. So these are two different things. Good. When we start running the inferential statistics, the modeling and what have you, we'll just get to understand whether what we are saying, no relationship will come to bear. So thank you very much. I want to end here so that we'll get enough rest, get the, what do you call it? You try and get the data set, you do it on your own, install the R software. I believe that your R founder will engage you and then give you the very needful thing to do, especially aid you to install. So thank you for listening. If there is no questioning, then I'll hand over to Francis. But if the moderator, if there's a, yes, somebody has raised the hand. John, please.
Yeah, good evening, Prof.
Good evening.
I'm very grateful to be part of your workshop, and I can say I really enjoyed it. By the way, please, will there be certificates after the workshop?
The R coordinator will tell you. They will tell you, Francis will talk to you about it.
Okay.
William.
Yes, please.
Yeah, I'm listening.
No,
Yes,
sir,
please.
there's a last concern I have. Sorry.
Oh, okay. So what is that?
Yeah, can we get the R script you are using on your R studios? Maybe just the one you are just using, and then you are just running the commands.
Oh, I would give all to Francis to be given to you. It's just
Okay.
that because maybe I've not finished. So per his arrangement, he will do that. Yeah. William.
Yes, please.
Uh-huh.
My question is on the part of the commands. Uh, when you were beginning, I saw you did something for all the commands to appear. So, like, my question is that are the commands already on the R system such that once you do something, everything appears for you to just be running them, or you have to, I mean, manually like input them and then save them somewhere so that you can just put them there when you need to use it.
I think for R, what is important is the packages. If you know the packages to be used for such as biostatistical technique, you don't have problem. So when you know your packages, then you should know the corresponding code that would make use of these packages. Now, all what you need to understand is that our language is our language. If indeed you are talking about how to find missing data, it is the same language. And for that matter, if I write the code, I can put it somewhere. Anytime I want to find the missing values, I can go and copy it and paste it there. But then I would be congruent with what we call the data I'm working with. I will just then change the data and I'll get my answer. So normally, the scripts, we have the script. We may have one that as we move on, we'll be writing the script. If I had done that, we would have kept long. We can't use even 1 minute because sometimes you write, you leave something, then you need to correct it. Then you see that the work becomes, you delay. But then the scripts are always written. And then you can also be doing it live with writing the script and going on. I don't have that time to be sitting there and then not engaging you properly. But this one is, I think, is efficiency. Good. I hope it's clear.
Yes, please.
Yes, who again? Okay, so if there's no other question, I believe that Francis has engaged you before. This is aid towards the conference. We are having every year, we have our conference. We exhibit serious, our packages and our insight for you to be able to do some kind of predictions and what have you, and it cut across all fields. R can cut across all fields. What I have done for you, irrespective of what, even if you are doing music, you can just use music data and you can use the same thing there. So it is not something that is so strange. It is something within your capability. and you can do that. So thank you for having me. Tomorrow to continue. I believe tomorrow's session will be short, so join early. That will finish. Francis, over to you, please.
Thank you very much, Prof, for the insightful presentation. It was down to earth, and then it was interactive. And I really want to thank all those who contributed. Yeah, so just we are ending by just some few announcements. So, as Prof said, this training is just to support our Ghana conference, which will be somewhere July 9th and 10th at the Accra Technical University. So, regarding certificate of participation, no, we will not be giving certificate of participation. But then we have our master class for beginners, our master class for beginners, which after this I will share the flyer with you. With that one, we'll be issuing certificate, and I think that one is just 50 cedis for 1 month. So that one need to begin somewhere 1st May. Then after 1st May, we'll be meeting every Tuesday and every Thursday. So it will be 2 sessions in a week, and then the time will be 7:30 to 8:30. So when you join that particular training, we will take you through the basics. As Prof was saying, I think some of you are a bit confused regarding about how to import your data, about how to analyze your data, about how Prof came about with all these courses. So when you join the basic training or the masterclass training, you get to learn all these things. And then also those who also contributed, or maybe those who are here, will probably add you to the conference group. I will share the conference group link on the page so that you join those who are here, because you've contributed to be part of, so you've just contributed to be part of the conference. So I'll share the link for you to join the page. Yeah, so automatically you are part of the Ghana Art Conference. So I'll add you to the page, but then you join via online. But then if you want to be part of the in-person session, you let us know. Yeah, so that's one of the announcements. The second one is that regarding those who don't have the setup, so when you check on the page, I just shared steps to get the R10 installed on your machine. So when you check on the group page, is there. Uh, just go online. It's free, as Prof said. It's open source. Once you go online, you get it done. If you have any challenges installing it too, you can DM me, or you can put it on the page, and then we will there to assist you. And then also, Prof was sharing with us the scripts and also the his presentation. So as and when Prof does that, I will share with you guys. And also, I also shared something on the page. If you have any questions to ask R is on Chat AI, so I just shared the R Chat AI link. So if you have any questions regarding R, you just click on the R Chat AI link, and then you ask AI anything, and it will help you resolve your issue. Um, yeah, so the recordings too will be shared. I've already shared the recordings already. It's on the page, so the recordings are on the page. Just click on the link, input the password, and you get access to it. Prof took us through a lot, and then you need to go through it. Once you go through it, I think you'll be good. But if you don't go through it, then you leave it for maybe 2 or 3 days. Once you take it, it'll be like something new to you. So please, let's take notice of it. And please, tomorrow I think we have to enforce some ground rules. Some joined and their microphone like it was on, and then I think you are disrupting the classes. So please, let's try and work on that. Because even this training, some of our partners joined from the global R community, from our consortium. They joined to just see how the training was going through, and they were very happy. They were very impressed. So this recordings will be kept on our YouTube channel. So once you go on our YouTube page, you get to see the trainings that we've done, our previous trainings, and even on our website, we have all the trainings there. We have all the books that you need to practice when it comes to R. So all the books are on our page, on our website. When you go there, you get more information regarding that. Yes. So I think I don't know whether I've left something out. Yeah. So tomorrow, as Prof said, let's try and join early. But those who are having issues installing the R, please tomorrow join early. As early as 6:30, I'll be on. If you have a problem regarding installation, kindly let me know. I'll walk you through before tomorrow's session. And then, if possible, we'll revise on what Prof took us through today before he comes home tomorrow. So, once again, thank you for your time. We appreciate your effort and everything. So, if there are no any other questions, we would like to end the meeting
Prof, hey,
in 10 seconds.
Francis.
Okay.
Yeah, sorry.
Yes,
Just a
Mr.
quick
Osman.
one. Yes, I kept hearing you say group. Are you referring to the main R community group, or there's another group that has been created?
There is another group that has been
I
created
think.
for biostatistics. Are you on
Oh,
that
okay,
group?
okay. Oh, okay. That's fine. That's fine.
Okay,
No, I'm
so
not. I'm not on that group yet. I'm not on that group yet. So
so
I'll
DM
WhatsApp.
me. Yeah, once you WhatsApp me, I'll add you to the group.
That's okay. I'll do that right away. Thank you.
Okay. So
I'm
please, any
grateful,
other
boss.
question? And any other questions? Okay, so thank you, Prof, for your time. We appreciate it. Thank you all for joining. So we'll meet tomorrow. So kindly check on the page. I have kept the recordings on the page. Go through it, and if you have anything, let us know. So I'll be ending the meeting in the next 3 seconds. Thank you very much for joining.